Share screen. All right, you see hacking Delphi's memory?
Yes.
Yep.
All right. Oh, by the way, it's too quiet in some of these things. So if you're not like in a loud place, go ahead and turn your microphone on. And I need to know when people are confused or happy or whatever. So
I'm always confused and happy.
all right. So anyway, this is the stuff that originally our client and our server were written in. And looking back, it just seems so primitive now. It's how did we ever do that? I've been working mostly with JavaScript lately, and the whole idea of debugging somebody else's memory manager is just crazy. So, all right, the App Store, circa 2000. What year was born?
She's 2001.
Yes. Okay. So this software is older than her. And yeah, it was amazing at the time. It's a shame that Delphi didn't keep it up, but it was amazing. And yeah, we had disks at the data center. Just I was afraid that I would never be able to get the old disks back. So this was the days of 32-bit Windows. It really didn't matter if we were willing to buy more memory. You could only get 2 gig for your program max and some more for the operating system. And memory was expensive too. So the prices dropped just so drastically over the last 20 years. So our solution was a lot of smaller computers. Our stuff breaks up fairly easily. It's, you can have one computer watching Dell and another one watching Microsoft, and they don't have to talk to each other. Helped a lot, but we were still pushing the limits. So one of the problems I ran into had to do with the default strings that came with Delphi. And most of the time, they were very usable. Pascal didn't really come with strings. So this is one of the things that Borland added to the Pascal language. By the way, does everyone know what a string is? I know the programmers do. Does that make sense, whoever?
Yeah.
Okay. So anyway, and these were the old days. Character sets, this was one of the problems that Delphi had while they couldn't upgrade. They added on language support later, but life was so much simpler. These strings were just bytes, and you didn't have to think about anything. For the most part, reference counted strings like you're used to with several asterisks added to it that I'm not going to get into. And because it's reference counted, copying is usually very fast and memory efficient, except I wouldn't be making this presentation if there weren't a few problems. And the one thing, as I'm scratching my head, I don't remember what made me even look at this. Once I got in there, I was deep in the debugger, and I can remember watching it copy things and update reference counts, but I don't remember what got me started that I would have to put the debugger on their libraries. So here was the problem. Simple case, here's a literal string, and I want to assign it to a normal variable. And it's very fast. All it does is copy a pointer. The reference count is set to -1 or something, just so it knows that this is special. And for one thing, it's copy on write. Usually you don't have that rule. Again, there were some kind of weird rules you had to watch for. And again, no change to the reference count. This is going to exist forever. It's in your program in the part that you wrote. All right. This looks very similar, except it's a field in an object. Oh, that should be : equals. Oops. This, again, I never would have thought it was different until I actually dove into the code and watched it in the debugger. But each time it does this, it would copy this string. And again, it's not just the 2 bytes here. There's a lot of overhead, and some things were larger. And I mean, how many, every stock has a block print alert. Every stock has a, every alert. Things get copied a lot. So I tried every which thing just to make the normal reference counting work, like copy it into a temporary variable and Oh, I eventually got it to work. It's hard to explain without 3 more pages, but I made it work so it actually share this like it's supposed to. All right. Another problem was fragmentation. People familiar with that? Memory fragmentation? Have you seen that? Heard of that? Dave's kind of nodding. All right. So the whole idea is that if you ask for a million little objects and Delphi goes out and asks the operating system for 5 pages of memory, well, what happens if you release all but 5 of those objects? You might have one in each of those pages and the rest of it's wasted. So that's kind of the issue. Well, there's a bunch of variations on that. When we were running the server, the operating system just said I was using more and more memory, and I thought there was a memory leak. But Delphi had a nice debugger for the memory, and it said, as I knew, we were allocating more from the operating system, and my program didn't have a leak. It was constantly requesting and returning memory. But the stuff that Delphi was holding on to just kept growing, like it had holes that we didn't have anything to put into. And not an unusual problem, nothing that I invented or first ran into. But just like in C++, you can add, it's almost identical, your own memory manager to certain classes. And I said, these are objects that we know the size of. It's at compile time, we know we're going to have the same object over and over. So I can manage the holes. I can say, here's a bunch of space that's only used for objects that are 20 bytes long. And that for the most part worked really well. Now it never returned the memory to the OS, but that's okay. It was just we decided in advance what we needed. And then when I copied all the Delphi code to C++, I copied this at the same time, and it didn't really help. I probably should have tested it sooner. Like I said, it seemed to be working, and I just blindly copied a bunch of stuff. But eventually, I found out it slowed down the C++ code. The default is just so well optimized, especially for multi-threaded programs. That was the difference. I had one big thing that was used by all the threads, and they spread it out. All right, this page is a little bit out of date, but pretty close. Mike found a bunch of the problems, and I looked over his shoulder and smiled. So yeah, we had some memory problems, and one of the concerns was that it was the same sort of problem, that somehow we were getting fragmentation again, and that would explain some of the things that Mike saw. So the memory manager, as I said, there's multiple domains or whatever they call them, that multiple heaps, basically. So you don't have the fighting between the threads. Of course, that means that it uses a lot more memory, especially in applications like ours. Our servers make a lot of threads because threads are useful. So yeah, forget this thing. My idea was wrong about the bug, and Mike corrected this. I thought he said GCC never gives back memory to the OS. I think it just sometimes doesn't. Like I was saying, the bad case when you have a little bit of memory spread out. So that was a little bit exaggerated. And we know that the top list in particular, and you'll see this in the next picture, they use a lot of temporary memory. So I thought maybe that was the problem. We allocated so much stuff that we never got rid of. And the worst case, each thread at a different time could be running this, and each one could maybe add a lot of fragmentation to a different set of things. So potentially it could be bad, but this wasn't quite it. Mike found this. Basically, we had tons of copies of the same debug information. I saved the user's custom formula basically until you close your alert or top list window. And we only used it in case of an exception. Now, exceptions basically don't happen. That's something that would cause the server to crash. So this was definitely debug stuff. And the real problem was very similar to what I was saying before. We had a lot of objects all pointing back to the same custom formula. And it should have been a lot of pointers, but it wasn't. It was a lot of copies of the same thing. So it really was, well, it's the same thing that happened in Pascal. It just wasn't the one I was thinking it was. There were so many different bugs. So yeah, C++ changed. I don't remember how many years ago. And the strings used to be copy on write. So, you know, I used them accordingly. They were cheap. They, for read-only data, you were just sharing a pointer. But I kind of read some of the background. I never really agreed with it, but basically, they said that there was no safe way to share strings. So now everything gets copied immediately. And they call this the small string optimization. That's maybe a little bit of an exaggeration. So in any case, I feel that I did my part. I tested the long formulas, but C++ changed under me. And I guess I never thought to, and I knew about this change, but I never thought about this one case. And it's not a traditional memory leak. The tools that I used before to find memory leaks, they would say, yeah, everything is good. Everything has been released. It's just for a short time, it was holding on to, or as long as the user had the window open, it was holding on to stuff. All right, so you can't quite read the scale probably, but this is the old one peaking at 3 gigs. And this is the, after the fix, 100 meg. So definitely a lot less memory. Some of these spikes, you can see this is the temporary stuff while we're compiling the thing and optimizing it. But then this extra stuff, a lot of it just stays around until we're done executing. So yeah, beautiful. Thank you, Mike. I mean, I've literally been looking for this on and off for years, and Mike tracked it down. So back to Delphi, there was at least one serious memory leak, something I wasn't returning that, it was just causing a lot of problems. And the memory leak and the fragmentation, they each did a little bit of trouble, but putting them together made it worse than the two of them separately. And basically the memory leak, it wasn't just memory, it really helped speed a lot too. So searching for memory leaks hurt everything. All right, related issue is the way we use CSV files. And I think I have an example, yeah. So I like to use them just as two-dimensional arrays. The top row and the left column say stuff like, you know, the top row will say price and closing price yesterday, and the left column will say Dell and Microsoft. And you can even have the file name as the third dimension. So this is a fancy way to look something up in an array, basically. And while you're using it, it's nice if this can all be in memory. You save and load from a CSV file. And let's see, yeah. So what I had to do in some of these cases, like the overnight data in particular, I had to do this in a streaming fashion. I had to write one line at a time out, and it made things harder. Like maybe we added a new field. I don't remember the last one we added, but we'll call it the expected price tomorrow. But we only have that for certain stocks. And when Mike tested, it was the first row had this extra field. But then the next day at 4 in the morning, they just came in a different order. So again, when everything was in memory, we knew the right answer. But here we're making some guesses, and in the middle of the night, it hurt us. But wow, it was great that we didn't just have to stop. All right. Oh, there's a few links in here. That's why I sent out this thing if you want to look up more stuff. But yeah, so these are the files it basically gets sent from one server process to the next. Like some of it's done by the overnight stuff and then read by the real-time stuff. And this is just such a beautiful format where for debugging, I can do this all by hand. I can write this for the program that needs it. I can read this from the program that is sending it, and I can even make small changes temporarily just to try something in the middle. Let's see. Oh yeah, so some of these are actually written by hand. In any case, yeah, if you don't understand this, Excel understands that. You can bring it up. JSON would have solved this problem. JSON didn't exist. Well, I take that back. There's reasons that we use this, and we didn't have as many options. And like I said, this is just so cool for input, output, debug. All right.
I have to say that I
Yes.
love that Phil is posting images from GitHub. That's pretty awesome.
Yeah, it's you know, at first I didn't really know that we needed GitHub, and there are so many other options. But one of the nicest things they have really is the website. It is easier to do that sometimes than to search my own computer.
Yeah,
So,
it sure is. Yeah.
I know there's other stuff too, the push thing, there's a lot of good reasons, but yeah, it's convenient for me to be able to do that. All right, so historical data. I've mentioned this a few times. You know, overnight we look up data for every stock and do a little bit of stuff. And basically we went to eSignal. That was our first data provider. And we didn't keep our own history. We asked them every night for the latest data. And it made it much easier. You know, they took care of corrections and splits and things like that. Hold on, I think this is my last slide. Yeah, we're almost out of time. So basically, I had to request the overnight data very carefully. Ideally, I'd say this is everything I want, and I'll start dealing with it as it comes in. I couldn't just ask for one thing at a time. There were ridiculous latency issues. So I had to ask for at least some data in advance. And some messages also timed out. If I asked for something, I didn't know how long to wait. Like if I asked for 10 things, I might get 8 of them quickly, and a 9th one after half a second, and the 10th one never comes. This rate limit thing, basically they just watched it and yelled at us if we did it wrong and threatened to cut us off. Ideally, their server would have done the rate limit, so we could have, I mean, that's how our stuff works. You can send 1,000 requests and we will put them in our queue on our side and rate limit if necessary. And then the last thing, again, I had to learn this on my own. I didn't document it anywhere. The message comes in compressed. It takes a certain amount of space. The first time I open it, the first time I need to know the price of Dell, it uncompresses it and it keeps both versions in memory. And it'll keep it in memory until I say I'm done with this message. So any shared stuff I had to be very careful with, and I just had to make sure I was dealing with it in the right order. And oh my goodness, I mean, the things that we take for granted now, and I guess there's no time for questions, but minute and a half if someone has a question.
So Phil, what is I assume C# just negates the need for any of the low-level memory management stuff. It's handling
Yeah,
stuff behind the scenes.
I have never written unsafe code. And for those of you who don't know, unsafe is a literal term there. And in JavaScript, it's not even an option. So I guess they're just doing better memory management, which is totally possible. I mean, the Delphi stuff was so old and there were so many things we had to redo. And some of this, we're just pushing some limits is all. Do you like these things? I have tons of old stories if people want more. I know
Yeah,
Dave,
I like
Yes, please.
I like them.
Yeah.
Yeah.
All right. So, and Mike, don't scare me. We don't have any Delphi running left, do we? Don't scare me.
We do.
I mean, we use a variety of cutting edge technologies, and I would have to check the specifics, but all of our stuff's
It's
great.
almost gone.
Yeah. So anyway, it's just it was fun. It was amazing what we did, and it worked somehow.
Okay.
Thanks, everybody.
Yeah, thanks,
you,
Phil.
Phil.
Appreciate it.